Astronomy starts with vision. That's not just because optical astronomy is still the primary way we learn about the universe, but because we have to see the universe. Astronomy is based on observation, as is most science. It's how we see the universe with our eyes or with telescopes. And astronomy, like most sciences, starts with observations of patterns in the natural world. That's something that's built into everyone. Humans are built to recognize patterns, whether it was a way of avoiding predation when we were hunter-gatherers, or a way of identifying food sources with the changing seasons. We're built to recognize patterns. We're really good at it. It has a survival mechanism, and it helps us as scientists too. It's important in astronomy and in science in general to see the world as it actually is. In this pair of images, we'll see a medieval view of how a cannonball travels. And this is based on Aristotle's mistaken idea from Greek philosophy of the 5th century BC, where an object does not have rest as a natural state of motion, and we can see the completely unnatural trajectory of the cannonball, based on physics that was essentially wrong. Moving forward to Leonardo's painting of a cannonball trajectory, we see the parabolic arc that later is described beautifully by Newton's law of gravity. In this example, the artist, Leonardo, correctly portrays the trajectory of the cannonball based on observation, even though he had no theory of gravity to guide him. The example of Leonardo reminds us that centuries ago there was not the artificial distinction between science and the arts that there is now, which is unfortunate in my opinion. Leonardo was a polymath who worked equally in the worlds of science, engineering, and math. Another example, perhaps less familiar, as an artist, was Galileo. He published his beautiful watercolor and charcoal drawings of the moon and the things he saw through the telescope. Because, again, remember this was before photography, before electronic detectors. All you could record was what you saw with your eye, and recording it exquisitely with a painting is one way of doing that. So in Galileo's drawings of the moon, we see the topographical features that told Galileo this was another rocky world like the Earth. A very important part of the history of ideas leading to the fact that the Earth is not unique. When we talk about vision, we can extend this to include other senses too. One modern technique in science involves sonification, or turning visual or numerical data into sounds. It's one way of understanding the patterns in nature. This was done by Kepler, who was the first to understand planetary orbits. He talked about the harmony of the spheres, by which he meant each planetary orbit could be converted into a varying tone based on the frequency of the orbital period and its perspective as viewed from the off-centered position of the Earth. In this audio version of that, we hear the harmony of the spheres as successive planets are introduced, with lower and lower tones moving out from the Sun. Kepler didn't originate the idea of the harmony of the spheres. It was an ancient Greek idea that came from Pythagoras. Pythagoras had a profound influence on all the scientists and philosophers who came afterwards, saying, for example, that the universe was based on number. And in modern science we believe this. We believe that mathematical, numerical theories underlie nature. Pythagoras also talked about the harmony of the spheres. He thought that this celestial music was such that only enlightened people could actually hear it. In this second example, we dramatically hear what the entire universe might have sounded like in the first 10,000 years after the Big Bang. This is the sonification of the interactions of matter and radiation in the infant universe, when the temperature was thousands, perhaps millions of degrees. We hear the ringing of the universe as these oscillating waves and particles interact with each other. Remember, this is the precursor state to a vast and ancient universe that eventually would contain 100 billion galaxies. This work was done by Mark Whittle at the University of Virginia, and it's a dramatic example where we compress 10,000 years into about 10 seconds, and because the audible range of the true physics is 42 octaves below what we could hear, we upshift it to come into the audible range. Vision is how we learn about the universe. In astronomy, initially it was with the eyes, and then with telescopes and electronic detectors. Vision also extends to other senses and to other parts of the electromagnetic spectrum. Vision and this kind of data is how we learn about the universe.